Okay, today we're talking about designing a low-profile hydroelectric work platform. So the design intent is to design a heavy-duty work platform that can be safely lowered and raised to accommodate the user, make it safe and easy to roll a pump or other heavy piece of equipment onto the work platform. We want to utilize a 120 volt AC hydroelectric power pack. So that consists of a pump and a motor, a hydraulic control valve. And we want to build the unit with common, readily available stock parts and materials, and have a high lifting capacity. Please note, video playback speed has been sped up in the interest of saving time. Let's begin. So in Fusion 360, and just a quick disclaimer, this video is not a paid promotion for any product that I'm using here in this video. I'm going to start off by making a sketch of the base using the sketch command. And this entire lift platform is going to be all steel construction. And I'll use the extrude command. So now I have a 1/2 inch base plate. Now I'll extrude up my 1/2 inch work platform. There you go. And that's work platform is what you'll roll the pump or the piece of equipment onto and raise it up and down to work on it. And the U-shaped base is what will be bolted to the concrete shop floor for safety with concrete anchors. Now I'm just going to adjust the platform so everything lines up on that front edge. You can use the push-pull command for that. Now again, back in sketch mode. You can always tell when I'm in sketch mode because you'll see this sort of graph paper grid on the screen. And so now I'm adding the C channel, the 2x4 C channel. I'm extruding it up. Then using the shell command, I'll turn it into C channel like that. Go 1/4 inch thick wall. Okay. Then I want to remove that little piece there. Use the cut command so it actually looks like C channel. Then I'll select that body and simply copy it, rotate it around, and place it where I want it. And these will get welded to the base plate, of course. Now, I find it's quick and easy to bring in SAT files from McMaster-Carr's website, so you don't have to model every nut, bolt, screw, washer, etc. It's a huge time saver. So I'm just bringing in the large guide rollers and the lock nuts for those guide rollers. It's a good idea to save your work as you go along. Now doing another sketch. I'm going to add the 2x4 rectangular tubing. That'll create the reinforcement frame that will get welded to the base plate of the actual lift platform. And again, using my extrude commands, and there you go. And then I want to also create a removable safety guard, again, made out of 2x4 steel rectangular tubing to fit in this front opening. So that way, once you roll your pump onto the platform, you'll put that removable safety guard in place to keep it from rolling off the platform, obviously, when it's up in the air. But it does obviously need to be removable so you can roll the item off and on the platform. I'm simply going to weld some tabs at a flat bar to each side. And I'll design those in the sketch command. And the circle is going to be a 1/2 inch diameter steel pin that'll fit down in corresponding holes in the rectangular tubing frame. Again, just create copy. And then rotate your copy around and put one on the other side where I want it. Just get everything lined up. Yep. Save your work as you go. So now I'm bringing in the hydraulic reservoir to make my hydroelectric power pack. I'm also going to paint everything a gloss red. Woo! And I do that under the Render tab. Now we'll add a motor, 120 volt AC electric motor. And this one's going to be face mounted. Now I'm just extruding a hydraulic pump that'll attach to the motor, and then that assembly will attach to our hydraulic reservoir. And something I wanted to show you, you can create a pattern to create the vent holes on the back of the electric motor. And the pattern could be squares, circles, pretty much any shape you desire. So I'm choosing a rectangular pattern, and I'm just going to make these circles row after row. And then once I complete this sketch, I will extrude or use the extrude command, but I'll use the cut command inside the extrude command, if that makes sense, to make the actual holes to make this look like an air vent for the cooling fan on the back of the motor. I click extrude, cut, and there you go. And now I'm doing an offset plane from the motor. And on that offset plane, I'll create a sketch and create the mounting foot for the motor, where it's going to mount to the main frame of the lift platform itself. Again, using the extrude command, paint it blue to match the motor. I'm going to make a square tube frame member that'll get welded to the base plate of the platform there. Then we'll move the whole assembly roughly in place where I want it to go. There we go. Now I'm going to add my hydraulic control valve. So when you move the lever one way, it's going to send hydraulic fluid to the cylinder to extend. When you move the lever the other direction, it's going to send hydraulic fluid in the other direction to retract the hydraulic cylinder. And we'll bring in the hydraulic cylinder here in a few minutes.
Woo!
And again, in render, just paint it black to make it stand out and pop. And saving my work. And here's the hydraulic cylinder I'm going to use. I'm going to make a mounting plate for it. So the hydraulic cylinder will bolt to that mounting plate, and then the mounting plate will bolt to the base plate of the lift platform. We'll paint the cylinder red. Now this pulley is actually a chain guide pulley for the ANSI chain that we're going to add here in a few minutes. I'll paint that red. And now I'm going to make the yoke that the chain guide pulley will mount to. And the yoke will simply thread onto the hydraulic cylinder rod. Again, in the sketch command. Then we'll extrude this shape up. Now create a new sketch. And now we'll create the notch that the chain guide pulley will sit down inside of. Using the cut command, create that void. Then we can lower the chain guide pulley down in there, like that. Looks good. And then using the fillet command, I'm going to just put a radius on those edges. Yep. And now we'll add a mounting pin that will go through the center of this chain guide pulley and through the yoke. Made out of steel. Yep. So I'm happy with that. Paint it red. And this is the ANSI chain that I'll be using for this project. It's a heavy-duty, high-strength chain, leaf chain. Kind of similar to what you would see like on a forklift. Now I'm going to make the chain anchor. So I'm going to bring in a large high strength bolt, and on the head of the bolt I'm going to model that to be our chain anchor. Because each side of the chain will need a chain anchor. So I'll create a sketch on the top of that bolt head. Say finish sketch, use the extrude command, create a new body, pull it up. If it's red, that means cut. If it's gray, that means you're creating a new body. Extrude it down a little bit. Yeah, I'm happy with that. Then create a new sketch on this surface. To create the two voids that the chain needs to be able to sit down inside of. Now again, using the extrude tool and the cut command, you can see how I'm removing material to accommodate the chain. And create new body. Okay. And there we go. And then I'm going to use one of these chain pins to make the anchor pin, and we'll elongate it to go all the way through this chain anchor. First, I just want to tighten up the openings here. That looks better. So I'm going to select one of these pins, copy it, move it down, and I'll select the end of it and I'll extrude it out to make it longer. And on these eyeballs over here in your browser, if the eyeball is crossed out, that means that body is invisible. If you click on it again, it makes that body visible again. Just FYI. And we'll paint the chain anchor black. And there we go. Now I'll place this roughly where I want it to go. Again, we can always move it around as we need to. And also copy the second one that you see there that we'll place where we want it here in a minute. And now I want to make the steel structure that the chain anchor will attach to. Needs to be thick steel, obviously, because there's going to be a lot of force or pressure exerted on this. And we'll extrude. So we made a piece of steel flat bar, bring it up about where I want it. And then we'll use a high strength lock nut. There we go. I'm going to make 2 flat bar stanchions that will weld to the base plate. Again, this is all welded steel construction that we're doing. And then I'll remove material I don't want. Just copy it, move my copy over, and there you go. And now I'm going to copy that, and this one will attach to the actual lift platform and be welded to the platform. And that's what's actually going to lift your platform up and down. But I also want to extrude some additional material and weld some additional material on the back side of the platform for additional strength. So I would have these laser cut out. Or water jetted to cut out these steel pieces. Then we'll attach our second chain anchor and the lock nut. Starting to come together. Yeah. So now I want to make the vertical tower, and we'll make that out of heavy duty C-channel as well. And the vertical tower is what our guide rollers are going to roll up and down on and inside of. So there's one of our guide rollers. Then we'll use the shell command. There we go. And again, we want the towers to be nice, thick C-channel because you don't want them to bend or bow or flex. I'll simply copy it for the other side. And again, these would get welded to that base plate as well. Just rearranging some things to make it fit better. And now I want to create a sketch on this face and extrude a cross beam out of some thick flat bar. And eventually we're going to make that detachable, and it'll just bolt to the top of the tower. And obviously that's how you'll be able to install the platform. And now we'll add the smaller guide rollers to this plate. And again, I just use the extrude command to make this plate and the fillet command to radius the corners. And these smaller rollers are going to roll on the outside of the C-channel tower. There'll be 2 on the front and 2 on the back. And then I'll simply copy this plate and make a duplicate copy of this plate for the other side. I'm just extruding out the plate, elongating it, and then radius the corners. And then these mounting nuts will actually get welded to the plate, and the guide rollers will screw into those weld-on nuts, just like that. And we'll add our lock nuts to our larger guide rollers. And this thick mounting plate obviously is getting welded to the actual red platform. And I'm just simply going to copy these 2. I'm going to radius that corner. So again, I'm just going to copy these 2 rollers and nuts. Now we have 2 on the front, 2 on the back side. And so that'll force the platform to move up and down nice and level and smoothly, and not bind or move or shift. And this whole carriage assembly, I'm extruding out the flat bar, and that will get welded to that side plate. Extrude out the other side to get ready for the other side plate that I'll attach here in a minute. Just copy it, move my copy over and place it where I want it. So you need to extrude that flat bar a little bit more. There we go. Do a sketch on this flat bar, and I want to make a reinforcement gusset. So I'll drag out a rectangle, finish sketch, extrude it up, new body. Then we'll do a sketch on the plate, cut out, there you go. And there's your gusset. Saving our work. Now we'll add another gusset to the other side, and same thing, copy it, place it where we want it. Then we go ahead and copy all of our guide rollers and mounting nuts, lock nuts, and move the copies over to the other side so both sides match. There are other online libraries you can draw 3D modeled parts from, not just McMaster-Carr's website, just FYI. And again, just copying the rollers to make some for the back side of the C-channel. Yep, attach the C channel to the frame, both sides, just like that. Constructing an offset plane. And now I'm going to create a line from one chain anchor up and around the pulley, guide pulley, to the other chain anchor. And then I'm going to use that line to create a pattern that will duplicate that ANSI chain over and over again to give the look of one long continuous chain. I'll say create, pattern, select the path, which is the line, the number of items. I need to stop about there and then redo that command to go around my radius. Do the same thing on the other side. Use the pattern command. And again, this 3D model is representational, so I don't have to get my chain exactly perfect right now. I just want to clearly illustrate this is a chain. Here's where the chain routes. There we go. Then I want to weld a reinforcement round bushing for this chain anchor to slide through, just to give the chain anchor some additional support. Paint it red. And I'm happy with that. Then we'll add our concrete anchors that will anchor this entire unit to the floor in the shop for safety. You just need to leave enough room to be able to get a wrench in there to tighten that nut. I'm just adding like a chrome finish to the concrete anchors. And I'll finish painting the base red. And so here's where we're going to make our removable top plate. We'll use the extrude command to elongate it. And again, this is just a thick piece of flat bar. And it will simply bolt to the tower. And these will be our mounting bolts for that. And saving my work as I go. And then I'll simply copy that bolt. I'll do that 2 more times for the other side. And there we go. So now I'm adding a limit switch that'll go at the top of the tower inside. So as a platform rises up, the platform will hit that limit switch and tell the hydraulic pump motor to turn off. So even if somebody stands there and holds the hydraulic control lever down, it's not going to allow them to continue to try to raise that platform past this limit switch. The limit switch acts like a safety switch. And it's adjustable, as you can see. I'm just adding some color in the render tab. And just a note, these power packs also come with a built-in internal relief valve. So if somebody did try to, hold the control lever down or up as the hydraulic pressure rises to a certain set point, it's just going to simply relieve itself back to the hydraulic tank. So you're not going to damage your hydraulic pump or any of your hydraulic components. And just about done. And so now I'm taking some measurements. I'm going to bring in some hydraulic fittings. And I want to try to model some stainless steel hydraulic lines that will connect our hydraulic cylinder to our hydraulic pump. So this is NPT by JIC fittings that I'm currently using. I'm thinking of changing that though to compression fittings or flared fittings. I'll see how everything fits. So just adding them where they would be on the side of the hydraulic pump here. And I can see I need to move my hydraulic pump out a little bit. Just making some fine adjustments. In render, adding some color. And I want to make a gusset that'll be welded to this squared tube upright frame member, just to add some additional rigidity, because that's a lot of weight, that hydraulic pump and motor assembly. Yeah, I think I want to go with different fittings. And we're going to be using 3/4 inch stainless steel tubing to connect our hydraulic pump to our hydraulic cylinder. Yeah, that looks better. I'm just trying to configure how I'm going to route everything so I don't have any interference or nothing gets in the way. Then we'll add fittings to our hydraulic cylinder now. But I believe I need the larger 1 inch. Yeah. So it'll be 1 inch male national pipe thread by 3/4 inch compression. And I decided to go with straight fittings. Yeah, that's better. Just simply copy it, move one down at the bottom. You still have room to get a wrench on it. Save my work. Then I'll create offset planes, and again I'll draw a line, and then I'll use that line to create my stainless steel tubing using the pipe command. You see I'm just drawing some lines. Make sure all your lines are connected. So you can see that line. Go up to create pipe at 3/4 inch diameter, and there you go. Now you could do a radius to make your corners not so sharp, but for this demonstration you get the idea. And then just using the extrude and the cut command to kind of connect everything, clean it up. And just removing that little piece there. There we go. Join those together. So we have one connection made. Then we'll do our bottom connection. And same thing, make a sketch, use that line, pipe command, 3/4 inch diameter, place it exactly where you want it. Create an offset plane, line it up with your fitting, draw your lines. There we go. Made that a little bit too long, so I'm going to shorten up that piece of tubing. I'm just trying to figure out exactly how I want to route the stainless steel tubing around everything. And again, I don't need a radius on my corners on the stainless steel tubing right now, because this is just like a proof of concept that we're designing here. Sort of a rough draft, if you will. Again, create an offset plane, draw a line, pipe command, place it where you want it. And there we go. I'm happy with that. So now our hydraulic pump and hydraulic cylinder are connected. So now I want to bring in a spring-loaded safety pin. So when the platform is raised all the way up and you have weight on it, you can install the safety pin. So if something failed, the platform would not fall. The safety pin would hold it in place. So we'll place the safety pin where I think it needs to go on the mast or the tower. And then I would attach a small steel cable lanyard to the safety pin so it doesn't get lost or dropped on the ground. So you can see how that would work. When the platform is all the way up, put that safety pin in. It keeps it from falling down in the event of an emergency. I want to paint the handle something bright, like yellow, safety yellow, so it stands out. That will work. Now I want to add an expanded metal safety cage or safety guard around the hydraulic cylinder. So I'll just bring in a piece of expanded metal from McMaster-Carr's website, and then I'll make an angle iron frame that the expanded metal will be spot welded to. And so that'll keep people from accidentally sticking their hands or arms anywhere near that moving hydraulic cylinder. So I create a sketch, creating my angle iron. And the angle iron can either be welded or bolted to this top member. I'm thinking it would be better to have it bolted so you can remove it as a separate item. There we go. And so I just copied the expanded steel to extend it where I want it. I was trying to create a plane here and then try to cut away the expanded steel that I did not want, but you see it started cutting away the other piece of expanded steel. I don't want to do that. I tried it a couple times, wasn't working how I wanted to. So to simply make a copy of it, and for this demonstration we'll just move it in place where we want it. There'll be a little bit of overlap, but not the end of the world. So now I'm just doing a sketch to make the vertical angle iron. And the angle iron frame will all be welded together, and we'll extrude it out. So I want it long enough to cover all the moving parts so people keep their hands and arms out of there. And then once I make one piece of angle iron, I'll copy it, move it over to the other side. And position it where I want it. Yep. And I was thinking about radiusing these corners again for safety. And then I just want a piece of flat bar welded here, and on the other side here, doesn't need to be angle iron. And I'll extrude out additional piece of flat bar here to finish out the bottom of this frame on this guard. And that will enclose the chain and that hydraulic cylinder for safety. Say new body. I was trying to see if they had a longer piece ready-made that I could bring in. That was roughly 1 foot wide by 3 foot long. Couldn't find one. This one was, you can see, too big. So I think I'll just continue to copy the existing piece of expanded steel and attach it on the sides and the back to finish out this guard. And again, the expanded steel will simply get spot welded to the frame. Saving my work. And then again, I'll just copy and add some more expanded steel to the other side here. Place it where I want it. Then I'll simply close off this last little section here. You get the idea. Now I want to add a decal, a safety decal that warns people to keep their hands out of there. You just simply go to Insert, Decal, and I brought it in from my computer, had it saved on my desktop. And then in render mode, we're going to paint the metal guard we just made in the expanded steel, paint it all red. Works. I think I'm happy with that. Here's our final product with the chain guard not shown. So you can see as you move the hydraulic control lever up or down, that'll raise your work platform up or down. And the way that works is as that hydraulic cylinder moves up and down, it's going to move the chain up and down, which obviously moves the platform up and down. So here's our 120 volt AC power pack, our safety pin, our ANSI BL546 leaf chain, our work platform with that removable guard in the front, and our limit switch, which is a safety switch, our hydraulic cylinder, and our concrete anchors. And here's a finished product with the chain guard installed, and you see a close-up view of what that safety decal looks like and says. And then of course, a back view. I hope this information helped. Please like, share, subscribe, leave me a comment, and thanks for watching.